Suppose you found a CD that pays 2.9% interest compounded monthly for 6 years. If you deposit $8,000 now, how much will you have in the account in 6 years? Round to the nearest cent. What was the interest earned? Now suppose that you would like to have $20,000 in the account in 6 years. How much would you need to deposit now? This is a 3-part problem, and let's start at the very beginning. We first must decide what kind of interest we're looking at. Well, we're definitely looking at compound interest, and since we're depositing a base amount versus putting monthly or even quarterly payments, since we have one lump sum, we're going to be using our compound interest formula. So let me write that down. So we need our compound interest formula. And what is the compound interest formula? Well, it says that the principal or future amount after n years is equal to the initial principal times the quantity of 1 plus r over k raised to the nk. And in this formula, let's identify all the pieces. P sub n means our principal or money in the account after n years. If you like, our future value, right? Our future value. P sub 0 is our initial principal. That's the lump sum that we start with and we put in our account. R is our interest rate. K is our number of compounds per year. And N, that's our number of years. So based on this formula, let's see what we can do to solve this problem. First part, if we deposit $8,000 now, how much will we have in our account in 6 years? What are we looking for? Well, we're looking for the amount in our account in 6 years, or our principal after 6 years, our future value after 6 years. This is what we're searching for. And what are we given? Well, we're given that our initial principal, or the money we're putting in our account now, is $8,000. We're also told what our interest rate is. Our interest rate is 2.9% or 0.029 if we convert to a decimal. K, or the number of times we compound, is going to be 12 because it says we're compounding monthly. And finally, N is our number of years, which is 6. Now, in my compound interest formula, I also have the expression NK, or N times K, and so I'm going to go ahead and just take N times K right here, 6 times 12, and that's going to give me 72. I have all my pieces, and now I'm going to put them into my compound interest formula. I have that P sub 6, or the amount after 6 years, is equal to 8,000, my initial principal, times 1 plus 0.029 divided by 12, all raised to the 72. Now let's put that either into a scientific calculator or Desmos and evaluate. I get that the amount in the account after 6 years is $9,518 and, rounded to the nearest cent, 45 cents. So that's what we fill in the first box, $9,518 and 45 cents. Now let's go on and work on the second box. For box number 2, we're looking at the interest earned. So how do we get the interest earned? Well, we're going to take our future value and we're going to subtract from it the initial deposit. Or using our symbols, what do we want to do to get our interest earned? We take P sub 6, the amount after 6 years, and subtract from it P sub 0. What is P sub 6? That's the amount we just found, which is $9,518.45. And we want to subtract from that our initial deposit of $8,000. When we subtract, we get a total of $1,518.45, and this is the interest that we've earned. So I'll put that in our second box, $1,518.45. Finally, we do the third part. Now suppose that you'd like to have $20,000 in the account in 6 years. How much would you need to deposit now? So this is a slightly different approach than we've taken before. Part 3. This time we're told our future amount. Namely, in 6 years, we'd like to have $20,000. How much do we need to deposit now? So this time our initial principal is what we don't know. We keep the same interest rate the same time, as far as 12 being the number of times of compounds per year. N is the number of years, so all of that stays the same, but our formula now becomes as follows. We have that $20,000 equals P sub 0, which is what we don't know, times 1 plus 0.029 divided by 12, all raised to the 72. The only thing that's different in this part is that we have our future amount and we're looking for our principal. So how do we solve? Well, we have to divide both sides of our equation by this amount right here. So I'm going to divide both sides of my equation by 1 plus 0.029 divided by 12 raised to the 72. I'm going to do that to both the left and the right side, and that's going to give us our initial principal. 0.029 divided by 12, all raised to the 72 power. In other words, I have that my initial principal is equal to taking $20,000 divided by this quantity, 1 plus 0.029 divided by 12 to the 72. Again, I either pull out my scientific calculator or Desmos and I calculate. I get that the initial principal needed would be $16,809.47. This is our third box, $16,809.47. I hope that makes sense. If you have any questions, don't hesitate to reach out.